Okay. So who do we got on the phone tonight?
This is Mary from 498.
Hey, Mary from 498. We got a bunch of 411. Were you in my 411 class?
I wasn't. This is the first class I'm taking with you.
Oh, okay. So you weren't, because a lot of my 498 students were in my 411 class, and they were sitting on the other side of the table. They were at one time doing 411, watching you guys do your show and tell stuff. And so now, like, they're now in the next, paying it forward, or however how that works. So, well, who wants to be my first volunteer for the night?
I can. This is Hero.
Oh, this is Hero?
Yes.
Okay. Well, let me just do a quick review for my 411 students. The 498 students get bonus points for themselves and their team by doing a very quick talk on any topic, but they only get 10 minutes. So it's show and tell. The purpose here is to show something that they know very well. Like, for example, some of the teams are using like Microsoft Azure, and I think I got a student who knows how to write Tableau and use R code in it. Okay, that's who is doing that tonight? That's Shanna. Shanna, you're doing that, right?
Hey, Don, that's me. Yep.
Yep. Okay, great. So the point is that if they show something, they show just enough that other people might be interested and might have a good starting off point. They get bonus points for doing it, and if anybody uses it, including a 411 student. So if you guys use something that you learn here tonight and you credit them, you will get bonus points for trying something new. But you have to credit them. You have to say, hey, Shanna gave me a great idea. I tried it. It didn't work out well for me, but this is what I tried. This is what I got. You'll get bonus points for trying it, and she'll get bonus points because she explained it enough that you tried it. So that's kind of how it works. Even 411 students, but make certain you credit them. 498 students in your final report, if you use Shanna's idea or Hero's idea, again, credit them and make it in a great big box so I see it. If I don't see it, no one gets any points. So that's kind of how that works. Okay. So anyways, Hero, you said you want to go first, right?
Yes, I can.
Okay, so you're going to have to share your screen, and I've been lately getting real strict on that 10-minute mark. So
okay, I remember 10 minutes. So which means that okay, 18. Okay, gotcha. So can you see my screen?
I can see your screen, but you'll have to. Right now it says you are sharing your screen, Hero. So you'll have to.
That's great. That's great. Okay, okay. Now I'll start. Okay, so this is not idea, but I just want to show the tool. This is very similar to Tableau, but probably easier than Tableau because of the functionality limited. And this is called Microsoft Power BI. I just disclosed that I'm a Microsoft employee, so you know. So the Power BI is a basic. Yes.
Hero, before you continue, this is called Power BI?
Yes, this is a Power BI.
And also, is this something free, or do we buy it? Or
oh, this is a free tool, but you know what? To get the full functionality, and you need Office 365. But as you see, there is the free version exists, so you can use free. But if you want to just use all functionality, then you need the Office 365.
Okay, great. Okay, get started. I'm sorry for interrupting.
Oh no, it's okay. So so this is a Power BI. So once you there is a two option. One option is doing the web UI version or at the desktop version. And I just show you the desktop version. So once you download the desktop version of Power BI, this is a main screen. And then this is a very easy. And how to do is just click the get data. And then go into Excel. I just downloaded about the illegal immigrant crossing at the border, Mexican border. That's actually at the cable data I just loaded. So so I loaded to Power BI, and then just a little take time, but okay, now it's already okay. So click arrest and then load the data. And then this data actually transfer from your desktop to this tool. And then here is a kind of the columns. First of all, and just as a quick example, so for example, you just choose like a border, and then I want to use the border as the slicer, so I change it to slicer, and then I want to bring the state, so I'll just bring the state. A minute, right here, state. Then like make it like this, but I just want to show a little more. I don't like this circle, so I just want to show you this like this way. So I like this way. This is a much better way. And then also I just want to show you the value. And what this value is basically just a minute. I will do just the first. Then the type. Okay, then I think the legend will be the type. Just a second. I gotta do here, and then I do type. Okay, now kind of much better. So what exactly I did is basically all illegal aliens, and then the Mexican people crossing a border every single year. And then first of all, I want to see just a southwest region only. So which is this is a southwest region. This is exactly controversial place right now nowadays. And then you see the number changed. If I go into like a north, just a minute, go the coast and go this way. If I change to the south, so which means that if I change the slicer and then the state information changed, and then also this information changed dynamically. So the first of all, create this kind of the public things, and then the next one you want to do is that save it to the desktop. So I just name it the sandbox 3. So I just do this way, and then next one is I'm going to publish to at web UI. So this is published into the website, which is a website of a Power BI. And then I'll go this way, and then okay, so okay, and then you see this is a URL. You can send it to your friends or anybody this URL, and your friend can access to this web page. And once you this web page, and then this is automatically push it down to the application of phone apps. And I already did it this afternoon, so I will just show you a picture. And I think I took a picture already. Just a sec. Let's see here. So this is a picture from see at the AT&T. You see at the top. So this is actually cell phone apps of Power BI, and then so same the report. It automatically push it down to the phone apps, so you can see on the phone apps too. And then the last stuff I want to show you is that you can also publish to PowerPoint. So if I do publish to the PowerPoint, and then the PowerPoint, just a minute, just takes time a little bit. So okay, just takes time a little bit. So okay, now it's okay. So I'll just save it to the desktop. So this way. And then go into my desktop, and then open up on this one, and then you see this is a PowerPoint slide, so you can send it to your boss or anybody else. So so this is pretty much the Power BI, and then again this is the basic function is a free tool, and then I think much easier than the Tableau. So I can recommend anybody. Don, I think that's about it.
Very good. I'm glad that you've got the whole idea and you did it in a very short amount of time. I think so. I guess what we can very quickly do is open it up. Does anybody have any questions for Hiro?
No, but this is Andrew. I use Power BI at work, and our integration in it is phenomenal. So it's
yes, yes. This is an R. If you click this, you can type that R script to the Power BI too. I didn't show because of the time, but yes, it's possible.
That's really powerful. If you have any slides or anything as well, you can send them, and I will certainly post. But from what you showed me here, it doesn't look like you even needed any slides. It was pretty much
actually I have a better than slide. Microsoft created a guided learning. So if you go into this website, and then there is a video class and post it. So if you just go through one by one, it's showing at the video. So Microsoft will let the instructor and show you how to use each modeling, visualization, exploring data, every single stuff in a video. So I think this is the best way to learn how to use Power BI.
Well, there you go. That's wonderful. And then it's just the website there is Power BI.
Yes, I'll send the link later. Yeah.
Wonderful. Thank you so very much, Hiro.
Okay, thank you.
And incidentally, for the rest of the people tonight, this is kind of what I'm looking for. Don't crawl into the weeds. Give enough stuff that if somebody else is like, hey, I was looking for a good presentation tool, they now see this, and it'll either inspire them to do it or not. But this is what we're looking for. Okay, who's going to be next on the list?
This is Andrew. Can you hear me? I'll go.
Okay, Andrew, you get to be second. What's your topic, Andrew?
Model ensembles.
Model ensembles. Okay, I love ensembles. Incidentally, 411 folks, if you want to try some ensembles when you're done here, make sure you make note of it because I'll give you bonuses for it. Ensemble models are really powerful.
Yeah, so hopefully my internet doesn't drop. It does sometimes, but let's see. It is, I got 816. Okay, so I will pass this on, particularly for 411 students, because these two techniques really help me in 422 and especially in 454. So I'm going to talk about two different types of combining multiple models together. You use it most often in classification, but you can also use it for regression. The more simple one is a voting or a means ensemble, where you have a collection of different models together and they cast a vote for what category they think they're trying to predict, and basically whichever one has the most number of votes you go with, or you take the mean of their predictions. You can adjust the per model weighting and do some stuff, but it's pretty simple, right? Make a bunch of predictions from a bunch of different models, add each row up, see who wins, and go with it. Model stack is a much more complex way of ensembling models. I'm not going to go into the weeds by any stretch. Just go Google model stack, KD Nuggets, or Kaggle. There's plenty of information out there. But sticking with the classification example, model stacks work just kind of like how you'd think a stack of models works. There's multiple models on a bottom layer, and they make their predictions, and you take those predictions to supplement the features in your data. So basically, after that's done, or you use those models to replace your features, and you have another model on top that uses the predictions of the models below it to try to make your try to get a more accurate prediction. So I'll go with ensemble first. That's the basic.
Can I interrupt real quick with a
Yes,
question? So you're saying that a model stack means that, let's say I build a decision tree, and the decision tree says Don Wedding is going to crash his car. Then what you're saying is that I take that prediction, and then we might put it into a logistic regression, and we say, okay, I got all this data, plus the tree thought Don was going to crash his car. So now I have all of the previous variables, plus the fact that the tree says Don is going to crash his car,
right?
And I now have an extra variable. Is that what
either
you mean
or?
by
Either or, right? You can either use one or two models to supplement your existing data, or in 454, I'd support vector machines, neural networks, KNN, logistic regression, and I took the probabilities for each class from all of those models, and then I put one more model on top of it, and just basically completely replace the features of the data with all the per class probabilities of the models below it.
I see that. I see what you're doing. So I believe that sometimes that's called boosting a model as well. So that's another term for stacking. Is I never heard that term before, but that's a powerful technique. So keep going with this. I didn't mean to interrupt or derail you.
It's complicated. Stacking has been winning all kinds of Kaggle competitions, but just a real quick example for how voting in either binary, multi-class, or regression works. Let's say we have 5 different models here, like logistic regression, and you can see that the majority, 4 of the 6 voted number 1, so that's the answer there. If I've got, take another example, the Super Bowl, who's going to win the Super Bowl? We have 5 different models. 3 voted for the Patriots, 2 voted for the Falcons. Then your ensemble is going to go with the Patriots. And then for like regression, you could take the average of all these. Now in the 422 course, there's a project where you have to do some combination of classification and regression. And I had some models that were much more accurate in classification than others, and I would give them 2 or 3 votes. And that really served me well, mainly because my concern at the time was some of these models did so well in the training data. I was concerned that they overfit the training data. So I figured that if I brought different types of models together, then I would not overfit and still maintain my accuracy. And then just like Don and I were talking there, model stacking, I use this in Predict 454. We use the forest cover. You can Google UCI forest cover as a very interesting data set for predicting what kind of trees are going to grow. And it's a very large data set, at least for me at the time. And so I had random forest, neural network, support vector machines, KNN, and each of those would predict what type of tree was going to grow there with the per class probability. And then on top of that, I ran XGBoost. And it's just another tip. If not taking time, when you get into R, I would strongly suggest that you take a look at XGBoost. It is like you were saying there, Don. It's an ensemble in itself. It's a boosted extreme gradient boosting, but it's a monster. It's complicated to work with. You have to do a specialized matrix data set, yada yada yada. But if you can get it to work for your prediction modeling, it is phenomenal. I couldn't beat it, even with my model stack and Predict 454.
That XG
So basically,
boost. Well, that XGBoost is that thing that keeps winning a lot of Kaggle competitions.
Yeah, absolutely. Yep. So what I tried to do at 454 for fun was combine all the other modeling techniques I knew that could spit out class probabilities, and I threw XGBoost on top of it and compared it to just XGBoost by itself, and I didn't help XGBoost. It did better on the raw data. And I think, yeah, absolutely. Integrating XGBoost or tuning it properly or integrating it with other models is absolutely cleaning up Kaggle competitions. It's finicky to work with, but there's 2 things for future 422 students. I would strongly look into the carrot package to help you tune model parameters and find what works best, and then XGBoost are really kind of more cutting edge techniques to play with that may not be covered in the course, but help me really push my coding skills. That was it.
Okay. Can we also get copies of these slides too?
Yeah, I posted it in the 498 course, but I can just email it to you.
Yeah, because I want to post it for the 411 students too.
Yeah, absolutely. There's a couple links I'll include in the email that have got really get in the weeds. I just grazed the surface, but it was a good way to push your skills and to see how far you can really do in some of the more advanced R classes.
Okay. So yeah, in the 411 students, you could probably do an ensemble approach if you were to get a prediction out of a decision tree, or use a couple of different regressions, do several different types of logistic models, and then average them together. That's an ensemble. Anytime you're averaging in any way, shape, or form, combining different models, you get that's called an ensemble. Incidentally, if anybody is interested, go out to YouTube and look up Wisdom of the Crowd. Okay? And you're going to find out where these guys are sitting here predicting how many gumballs are in a jar. It turns out you get like 500 people predict. None of them gets it right, but when you get them together and they average it, the average is extremely accurate. It's the same principle with an ensemble. You get a bunch of models, and they're dancing all around predicting who's going to crash their car. But when you get them together and average it, you end up with something better. So ensembles are really powerful. So, anyways, thank you very much. And that was who was that again that was talking?
Andrew. We're going to use this technique in our loan lending club project.
Okay, you're Andrew Hans, right?
Yes, sir.
Yeah. You were in my 411 class.
Oh, yeah.
I remember you. Okay.
I feel like I could make money on baseball scores after that course.
Yep. They just finished. This guy just finished ball.
Can I ask a question? Quick question. Can I ask a quick question?
Sure, go ahead.
Yes, Andrew. Yes, I'm interested in XGBoost too. So could you send me some kind of nice kind of reading material on XGBoost? I already read the XGBoost kind of official one, but just not easy to follow. So if you know any good websites to learn at XGBoost, that'll be nice.
Hero, you're in my 498 section, right?
Yes.
Yeah,
We
yeah.
are.
Go in the information sharing discussion board. I've got a write up, and I posted my code that takes a lot of the it'll actually allow you to send it data frames, and it'll determine whether it's a classification or. So yeah, just go to the very bottom of that and send me an email. I'll help you. But I got a big write up and my code for it in there.
Oh, thank you. That's great. Thanks.
Hardest part about XGBoost is using it.
Yeah, that's what I heard. Yeah, that's what I heard.
Okay, thanks.
Well, I've never been able to figure out how to use XGBoost, so now I'm going to have to go grab that code too. Probably post it if you don't mind, can I post it for my 411 students going forward?
I just no expressed warranty or implied warranty. It's a work in progress.
Never a problem. So, anyways, hey, so thanks very much, Andrew. Who's next on my list?
This is Mary. I can go now.
I can go.
Oh, well, who was the first one to spoke? What was that?
Mary.
Mary, you get to go next. Shanna, I guess that was you next, right?
Yep, but I can go afterwards.
Okay, best for last, right? We're going to save the best for last. I'm just kidding, Mary.
That's right.
Mary,
that is right.
Mary, what's your topic today, Mary?
I'm going to be talking about an application for factor analysis and regression to validate surveys. I do a lot of this in work, so it's more of an application for outside of class, I guess, or it can be used in class.
Okay. So Mary Williams, factor analysis, huh?
Yeah. Can you guys see this?
I can.
Okay. So I'm part of an HR team within Cisco, Team Analytics and Research, and we focus a lot on, handle all of the surveys that go out for Cisco. And right now we're working on validating one of our surveys that we call the Real Deal. So I'm going to go through the 3 different ways that we're doing this, and it's kind of step by step. So the first type of validity that we're proving is content validity, which is really just, do the questions make sense? Construct validity goes into the relationship between the questions of Real Deal. So that looks at a lot of correlation and Chromebox alpha and factor analysis. And then the criterion related validity is comparing the unvalidated Real Deal survey to a validated survey that we have called engagement polls, and that uses the regression aspect. So again, content-based validity is pretty simple. It's just relating back, do these questions make sense for what the intent of the questions are? We use correlation plot for this. There really is no measure of good or bad. Again, the correlation is just used to relate back to, okay, does it make sense for these 2 questions to have a high correlation or a low correlation, things like that. Construct validity gets into the factor analysis in Chromebox alpha. So at this point, we're measuring the Real Deal itself to see how related the questions are and what those underlying constructs and latent variables are. So that's why we use factor analysis here. It identifies the relationship through latent variables, and using the orthogonal rotation really gets to that point of what aren't we measuring that could be related within these questions. And Chromebox alpha is just another way for reliability. You're looking for an alpha between like 0.6 to 0.9 to show that you don't have repetition within your questions. So I did that here. We see that the survey items split into 3 different factors. Factor 1, we labeled as a common theme of psychological safety or safety and trust within groups. And really this survey is getting at, or the intent of this survey is to measure the pulse of the company at the time. So going along with that, factor 2, we've identified as company alignment and growth based on those groupings of items. And then factor 3 is strategy and processes, again, based on those groupings of items. And this also goes into some of the details as to why we chose 3 factors based on the eigenvalues and the overall alpha, which we found was actually a really good measurement of reliability. Okay.
What did that bold-faced ones mean? Like
good question. So one of the things that we're trying to get out of this is this survey has 14 items, so 14 questions. We're trying to get that down to 10. So what the bold-faced ones are the items that loaded in more than one factor. So for example, you see real deal 13 in factor 1 and factor 2. So we're exploring those for possible removal because they cross-loaded into more than one factor.
Got it.
And then, so that basically at this step, we were able to conclude that there are 3 different things being measured here, possibly, and that there is reliability in our survey. So the questions, this helps explain what is going on within these items and questions. Next is criterion relatability. So this really gets to what the real deal is actually measuring when you compare it against a valid survey. And it helps us with confidence say that it is valid if we find that. So what we're trying to do here is use the real deal items to predict the engagement pulse. And again, the engagement pulse is a survey that is validated. So we're using regression here. We take each of the 10 real deal items and create a regression model with the first engagement pulse question as the response, and we do that for each engagement pulse question. So we have 10 different models at that point, and then we also ran it through stepwise forward and backward regression. And what we're trying to get out here is really to understand which real deal items predict the aspects of engagement. And to be honest, this is a work in progress right now. I just completed it today. So as an example, this gets to the results of the model. We were able to find, for example, that these real deal questions here that I'm showing predict engagement pulse 1 with the different metrics that go along with that for validating the models and measuring it against other models. So what this means in business terms, we're now able to conclude that the real deal survey is validated. So again, as a measurement of aspects of engagement. So that tells us when we're presenting this survey and telling leaders, executive leaders, about this survey, why it's important, and that we have confidence in saying that it does measure aspects of engagement, and that gives more value to why they should pay attention to it and really consider the results that come out of it. That's all I have for you guys today.
What software did you say you used to create your factors?
Okay, so I did R for the factors, and then SAS for the regression.
Okay, can you post the R code for factor analysis and hell, the regression? Well, do both if you want to, of course.
Yeah, I can do both for sure. I'll send you this and the code and post it in 498.
That would be great, and then because that way the students from 411 might be interested in doing factor analysis.
Yeah, I really like factor analysis now. It's used a lot in psychrometrics, which is kind of the field that I'm in right now, being in HR and working with a lot of surveys. So it has a very interesting application to it.
Yeah, I was going to say that factor analysis is not used a lot in a lot of fields of analytics, but in surveys you see it a lot. So that's it. And that's the other thing is you're going to find something else going forward in your analytic careers is there's never a bad technique. It usually some tools may not find wide use in some fields, but they all have, there's a reason that they were created. They will have a specialty use or a field where they really shine, and factor tends to be used a lot in exactly this. I don't know much about factor analysis, but I know they use it in surveys a lot.
Yeah. So I have a new appreciation for it. So.
Yeah, it's like clusters. It can be a real art to it.
Yep.
Okay, Mary, thank you so very much. And Shanna, you're next. And this is one that I've been really eager to see because this is how to write our code inside of Tableau. And according to Hero, he says we can also do the same thing in Power BI. So it's possible that what she's showing us here might segue back into what Hero showed us. Okay, Shanna?
Thank you, Don.
Amazing.
Yep, and that's a good segue because I was going to start off by saying I feel like I'm in competition with Hero. So what I leave you all with is a flavor or an appreciation for why you might want to integrate a BI tool of your choice with a statistics package of your choice. Because while I'll be showing you how to integrate Tableau with R, you could integrate Tableau with Python. And I'm sure over the years, Tableau will add more straight-through integrated packages to integrate through other tools. So the idea here is to give you a flavor for what can be done and how you add value by combining the two. And really, the sky's the limit once you do that. So can you all see my screen?
Nope, not yet.
You don't? Oh, okay, hang on. I thought I was sharing
You have
it.
to share your screen.
There we go. Do we see it now?
Yes, we do.
Okay. So, Don, do the 411 students have the PowerPoint yet?
Not yet, but I'm hoping I haven't forwarded it yet, but you emailed it to me and I'll post it with everything else.
Perfect. Okay. So Don will be sharing this PowerPoint. It is 17 slides long, and it does walk you through a step-by-step example. 10 minutes obviously doesn't allow us to do that. So I will give you, like I said, the ideas of why you want to do this. I will show you what you can accomplish, and if time permits, maybe we'll do one or two things hands-on, or if not, you'll be able to do it on your own without any problems. So the first question is, why bother? Why do I need to integrate any BI package with a statistics package? So focusing on R in this specific example, R provides statistical capabilities far beyond what Tableau or I think any common BI package offers. Besides which, all these packages allow you to write your own user-defined functions. So very often you need to go way beyond the standard offerings. Okay, so why not just use R if R is so great? Moving over to Tableau or the BI package of your choice, Tableau provides much nicer visualizations. Tableau enables analysts to quickly author dynamic and interactive dashboards, and that's through the power of drill downs and filter capabilities and parameter controls and so on. And finally, most importantly, do you think your CEO, Don, wants to write R code? And what I meant by that was a manager hires an analyst onto the team, and that analyst is doing some great statistical work in R and wants to show the manager what he or she has accomplished, and he brings his laptop over, hooks it up to the big screen in the room, and the boss says, okay, well now let's try it with A, B, and C, and he says, all right, here, take the laptop and you start driving and try all your what if analyses. That's not a whole lot of fun. When you marry the two, you can create these dashboards with a lot of what if capabilities that hook back into that fancy snazzy R code, and the boss can now interact offline even if you're not sitting next to him without writing any code. And I think that is what happens when you put the two together. You really get the best of both worlds when you marry the two. So the sum of the whole is really greater than the parts. One other point that I'll add here is that I didn't put in the slide because it's not true in every scenario, but it's true in many scenarios, is that a lot of the modern day BI tools have used what they call in-memory solutions, which means in order to enhance the performance when the analyst is doing their aggregations and creating their snazzy charts, they first go out to the data source and grab all the data that the analyst that they're going to need and bring it into memory. That's really great from a performance perspective up until you have too much data, and then the whole thing just crashes on you. So when you hook it up to a tool like R, you can shove all that heavy lifting and the aggregations to R to serve as your backend, if you will, and then R can ship back the nice results to Tableau. So that is another potential reason why you'd want to do this. Just to show you that the setup is really easy. In R, you install the rserve package, and you literally type library rserve to start up the server, and that's it. You're done on the R side. In Tableau, you would go ahead, open up help settings, and just literally type in localhost 6311, and now you're ready to really start. My next few slides here will actually take you into a step-by-step example of how to do this. Again, 10 minutes will not allow us to do that. So I'm going to actually just over here. And do you guys see Tableau on my screen now?
Yes, we do.
Okay, so this is an example that if you follow my PowerPoint, and I did follow it step by step, so hopefully it will get you to the same point. You should land here. Additionally, I used the Moneyball data, and I know by now you've all had a ton of fun with Moneyball. So you do have this data set, and I did give you the R code, so hopefully this would work for you. So again, just switching over to RStudio real quick, I'll show you my R file here. Some very simple correlations and k-means clustering functions. You write them up in R, test them in R, make sure they work. You really don't want to put up code there and then start going into Tableau and trying to figure out why something's not working. You want to make sure it's not sitting on your code side. But you have it there and you can use it. Coming back to our little example here, one more disclaimer before we actually go hands-on. You all probably did that cute little neat bonus assignment for Don already. You should never use R squared alone as a diagnostic for determining if you have good models. So this is purely for illustrative purposes. Obviously, if you were connecting to R, you'd probably be doing a lot more advanced work, but this is just to show you what this can do for you. So if you follow the PowerPoint step by step, you'll set up the ability for a user to choose a response variable from the list of variables available. And in this case, I chose to set up two predictors, basically two measures. So you can set up any one of these two. And you'll see that as we set this up, our little charts down here should start changing. It's literally going out to R as we're doing this. And it shouldn't take that much time because it's all local and it's not a very large data set. But bear with me. There we go. And we now have an updated chart. And basically, you know, going back to you're sitting next to the boss and you say, hey, boss, I think that there's a high correlation, or negative correlation between, you know, the amount of runs that are batted in, and I don't know baseball, but the amount of runs batted in and the wins. And the boss says, well, I don't think so. Let's see if, you know, home runs would have a bigger effect. And you literally can take that drop down. It'll go out to R. It'll recompute the information, and you should see the correlations. And this is a Pearson's correlation update over here. And we should see an adjusted R square change. And basically what it's doing is it's computing a linear regression model where it's regressing these two predictors that you've chosen on the response variable that you've chosen. And just to show you that it's not magic, here are the functions that correspond. Here's my multiple correlation. So I'm sending in any n number of predictors and a response variable, and it's going to ship that list of correlations back to Tableau. And down here, I have my multiple linear model where, once again, I'm shipping a response and any number of predictors to R, and it's going to run that regression model against those predictors and ship the summary, the piece of the summary, which is R squared in this case, back to Tableau, and Tableau is going to save that. Another interesting thing here is that I'm sure Don has spoken to you a lot about the potential of outliers influencing your model. So you might want to see what effect that would have. So, you know, down here you saw you had a lot of outliers and you thought that might, I don't know, be making that correlation go one direction or another. You can literally go right here, start filtering out data, and once again, it'll ship the new data set back out to R, recalculate the information, and send it back to you. So again, my point in showing you this was to show you that it's pretty simple to build this, and more importantly, the power of giving a non-coder the ability to really tap in to the work that you've done in R, and all they have to do is, you know, press some buttons and interact with some widgets, and they can get the information back in their face. So I think we're at 10 minutes. So I don't think we'll have time to build it up, but I'm happy to take questions.
Can you also post your R code and data as well so somebody could walk through this?
So the R code is actually, I believe the R code is in my presentation. I have it right here. I've got all the functions here, and it's copy pastable. So
that's
all of that there.
Because I saw a bunch of R code that you showed on the screen from RStudio, so I just assumed that it was a lot more.
So the only extra R code that you might have seen was my own way of testing it in R. So I didn't want to have to test by shipping some information from Tableau back into R. So I'm literally reading in Moneyball here and then calling the same functions that I would call from R with the Moneyball data. That's all.
Got it. Okay. How long did it take you to learn to do this, Channa?
Not long. Spent a couple nights on it.
It looks
But
hard. Well, I mean, it's impressive though.
I would say that, believe it or not, sometimes actually putting together the presentation takes longer than figuring out. There's a little wiggly niggly, so, and this is why hopefully by giving you the code, I'll save you from that. So for example, let me just go down here. In Tableau, you're going to create a calculated field, which is a standard feature of Tableau in order to tap into your R functions. And there's some little extra type of syntax that you have to put into Tableau. I had to do a little research on that. And there's some little rules like, oh, you have to aggregate the predictors on the response variables. And you're not really aggregating them, you're just tricking Tableau into doing it. So I had to learn some of those wiggly nigglies, and that's why I'm saying I'm hoping that this step-by-step example tutorial will save all of you from that. So that's kind of where I spent the most time. But Tableau itself, I find easy to use. And the BI tool you showed is also easy to use. So it's a standard, easy to use front end. And R, we've become pretty comfortable with over the past few classes in the MSPA program. It was just putting them together that took a little bit extra time.
I like this very much, especially I like the term wiggly niggly. So I'm gonna.
It's in competition with Proc Eyeball.
Yeah.
It's technical like that.
I see. I like it though. So thank you very much. Does anyone have any questions for Shanna? I'm getting kind of interested. I'm starting to try to learn Tableau right now. That's another thing on my list, my bucket list. So I'm going to try to do that with the R stuff here. So I got nothing else there. Thank you very much, Shanna.
Sure, and I'll just add that I actually added 2 challenges at the end here. So Don, when you do it, I added challenges where I didn't give you all the code and all the answers, but for the KNN, I do have it. This is not just a fake out mock-up, so if you need any help, and the offer is out to anyone. If you have any questions, just give a holler.
Thank you very much. Does anybody have any questions for Shanna? I think we got a chat. Let me see if anybody on the chat window. Thanks for walking us through this. That's neat. Well, there you go. Does anyone, do we have any more volunteers for the night?
Yeah, this is John. Hi.
Hey, John, how are you doing?
Great. How you doing?
Not too bad. You're next on my list, huh?
I'd like to be, yes.
Okay. What's your topic, John?
It's a complementary discipline to predictive analytics. I know we're all excited about predictive analytics, but where this really opened up for me and I saw the heavens was when I got into prescriptive analytics or operations research, which is kind of like the next evolution beyond predictive analytics. So predicting what's going to happen is cool, but making it happen is even cooler, right? When you can actually come up with some decision variables and say, if we do X, Y, and Z, we're going to get these results. So for me, that was magic, right? So I'd like to just walk.
Are you sharing your screen?
I am just about.
Okay. Well, I'm excited already. I think this is going to be interesting. So this is basically taking what people learn here and applying it.
Yeah. It's the next phase beyond predictive analytics. Yep. So can you see my little graph here?
Yes, I sure can.
Okay. All right. So I just want to give everybody a visual aid to kind of see what's going on here. And in this particular baby example, right, we've got 2 variables, an x1 and an x2, and there are real life constraints that we can put on these, right? So in this problem, you can only make 4 of x1 and you can only make 6 of x2, right? So that's this horizontal and vertical constraint lines here. And then maybe you've used some predictive analytics, right, to come up with regression, right? And you've identified some relationship, right, some correlation between x1 and x2, and you come up with this other constraint, right? And that's really the hard part of operations research. Solving these problems is easy. It's coming up with the real life constraints that matter, right? And spoiler alert, this feasibility range here where there is an optimal answer, right? Like we're going to find some maximum profit or some minimum expenses. The the best solution is going to occur at one of these corner points. And in this two-dimensional problem here, it's very easy. You could just test all 5 and be done for the night. But when you start getting into higher dimensions, right, so you've got like 20 variables, right, you got 20 dimensions, you can't spot these corner points, right, obviously. And there could be infeasibility ranges as well, right? So maybe there was something here that, you know, you didn't have, I don't know, these top constraints, and this thing went on to infinity in the positive direction, right? So there's all sorts of things you can't see, right, in higher dimensions, but these tools that you'll learn if you take an operations research class. Dr. Bastian teaches special topics in decision analytics. If it becomes available, I highly suggest you all take it. It's awesome. But these tools enable you to solve these multi-dimensional problems. And when you look at these problems, and you're like, wow, how the heck would you ever solve that? And then you come up with this algorithm to do it. And you're like, wow, this is so cool that you can turn the world into math, solve the math, and then come up with a real life answer. So as an example here, I wanted to just walk us through a baby example so that you can see what's going on. And in this example, a small foundry needs to schedule the production of 4 different castings during the next week. And below here is how many minutes it takes to make each product, right? So you've got 5 different operations in this factory. And to make product A, you need 3 minutes of pouring and 8 minutes of cleaning and all this good stuff here. And these types of things, you might not have. You might not know how long it takes. And that's where predictive analytics, right, sets you up for these kinds of problems. You've got to analyze your system to figure out how to get these numbers. But once you have them, you can start putting them into equations. So in this particular problem, right, we've got profits for A, B, C, and D of $18, $15, $13, $14. And there's an assumption that if you make it, you'll sell it. Okay, so we don't have to worry about storage expenses and such. And then there are additional constraints, maybe like contracts here. They dictate that we need to make at least 200 units of product A and 300 units of product D. And we've got some work constraints, right? We only have so many hours in the week for each of these operations. So you put all this together and you say, well, gosh, how am I going to figure out how much of these products I need to make? And it's always very important to solidify what you're trying to do in a one statement, if you can, business question. What are you trying to do, right? And I know it's something we're definitely focusing on in 498, right? What is it that you're trying to do? Make it clean and concise. And in this particular problem, we're trying to figure out how many of each product to make next week to maximize the profit. Now, here's some math speak, right, to kind of set the problem up, right, to turn all these words into math. You come up with some sets, right? So you've got your products, you've got your operations, and then you've got these variables. And these decision variables, that's what you're changing, is the number of units of product I, right? So those are your X's. And you've got some variables here, the profit you make for each product I. And you've got the hours it takes to complete process N for product I. And these things can get very complicated. This is a very simple problem, but it's very important to lay this out so that you don't get lost. And then here it is. This is where the math is, right? This shouldn't be scary to some mathematicians here, is that we're trying to maximize this summation, right? So we're going to make however many of these X's and make this much money on them. You add it all up, that's your profit for the week. And you take into consideration constraints. Well, that statement previously is like saying, okay, my X1 is bounded by 200. I have to make at least 200. And same with 4. I've got to make at least 300. And you have those time constraints. So you get all these great summations in here, and you have a maximum threshold there. So these are all less than or equal to's, right? And then typically in these real life problems, you have something like, hey, you can't make negative things, right? Because that's just stupid, right? So you got to have some non-negativity constraints. And then a lot of times too, whole numbers, right? Nobody wants half a car. So you got to make whole products. So then this is where it gets cool. You put it into Excel, right? You set this problem up and you say, okay, I got my products and I got the things that, the minutes, right? The minutes of operations that I need to make these things and my profits. And then you've got, let's say 1 here, all right? So that takes, to make one of these items, it's going to eat up some of your time, right? And so you build these equations in here to do all this cool stuff for you. Here's going to be your revenue, right? These are your time constraints converted to minutes because you're given hours. And then all you got to do is use this package here, solver, right, in Excel. It's, comes free, you just got to add it in. You set it up. You say, I want to maximize my profit by changing these variables right here. And then here are your constraints. I need integers, right? There were some time constraints, some resource constraints. And if you set all that up, you hit solve. It'll tell you if you've got some unbounded problem. But if, it'll say can't find an answer. But if it converges, it'll say, okay, found an answer. Do you want it? You say, yeah, I want it. And there it goes. It goes and figures out you need to make 200 of this, 67 of that, 343 of that. Your profit's going to be 9,400 bucks, and done. And it's insightful, right? It's telling you that product 3 here, see, right? It's saying don't make that. So there's a problem with that product. That's not profitable. Or you've got no slack with these, right? You're cleaning and grinding here. You're maxing out your hours. So if you wanted to make more money, that's where you put your time, right? You don't want to put more time into pouring. You've already got too many hours there. So these kind of problems help you now make real life decisions, right? So it's and to get here, you need the predictive analytics, because all these numbers don't grow on trees, right? You don't know these things necessarily. You've got to go out and build models, get relationships, and then you can build something like this at the end. And this makes everybody happy, because this is where the money is. This tells you how much money, how much to make. Easy. You don't have to decide anything now. So that's my pitch. Take operations research if you can. It's awesome.
That is cool. I have 2 questions. Question number 1, how did you get this package? And second of all, how did you tell it had to be an integer?
Yep. This package is actually an add-on. If you go into Excel, File, Options, there's a add-ins here. And there's all these packages that come inside of Excel for free. And you go to go, and here's the things that are installed. And I just check solver add-in. And then it's a quick reboot, and it's already ready to do this. There is a limit in Excel. You can only solve problems with 200 decision variables. So keep that in mind. In bigger problems, it doesn't take long to exhaust that. But there are solutions outside of Excel, like we were using Gurobi with Python to do some things. But typically, if you get into like the really high level stuff, you got to pay for that. But this is free if you, beyond the cost of Office, which is typically expensive.
How did you tell it was an integer then?
Yep. In the solver is it knows, it's intelligent enough that you can you can put in the constraints, and in fact you can even do, like down here, this make unconstrained variables non-negative, because that's so often the case that it comes with a checkbox. So this thing's pretty smart. It kind of knows what the what the pitfalls are going to be your data, right? It knows that most times when you're making things, for example, you don't want to make half a thing. You could get a more optimal solution, and that's why you have to be careful, because if you didn't specify that, it might say, oh yeah, we need to make 200 and a half cars, and you'll get an extra $5. Well, you're not going to really get an extra $5 because nobody's going to pay you for that half car. So these right here, right, these things here are the exact same thing you saw in the solver. I just put it on the spreadsheet so that you could see it, right? It's just easier to see it here than built in all those equations. But yeah, here's those are the minimum contracted requirements, and these are the maximum minutes. But yeah, it's just another constraint that says, yep, I only want integers. So you just say these cells have to be integers.
Cool.
And then you hit solve. And then yeah, if you wanted to add more constraints, you do it over here. You can delete constraints. I already built it to save time, but yeah, use something like this, right? This is a nice little template, and then you got a new problem. You just shuffle it around, and these are all equations. So I'll definitely share this file so you can see how these things are calculated. It's nothing but products, right? It's nothing scary. There's no wild formulas in here. It's just a bunch of products and sums.
This is really interesting, and you'll send us the Excel spreadsheet, of course. That you just said that, right?
Yeah,
perfect.
Yep. I'm going to send the spreadsheet plus the this thing so you can kind of follow the math behind it. Yeah, both of them, so you can get a flavor for this. But for me, this really, this is kind of one of those life-changing things where you say, wow, this is how you operate the matrix, right? You can start looking at the whole world as numbers now. You can turn these words into equations, solve the equations, and then spit back out word answers, right? It's really, really awesome.
This is impressive. This is something I could do. I mean, I'm looking at this going, yeah, this is something I could use and also figure out pretty easy. Let's open it up. Anybody have any questions for John? I think you wowed them there. Stunned silence.
Great.
I'm impressed. This is really cool.
Yeah. Well, Prof B is a great resource. He does this for a living for the military, and he does things far more cooler than this problem I've shown you. I mean, he's scheduling medical, operations, take-down time, the time it takes to get a patient off the table. I mean, they're saving lives, where seconds count, and they find these optimal ways to, move people around the world, and it's all this. It's just what's the maximal or minimal, whatever. And it's pretty cool. So reading some of his papers, he also works with Dr. Fulton, but they, yeah, it's really cool stuff. Definitely something you at least want to take a look at.
I think this is impressive. Well, any other questions or? Well, okay. Do we have anybody else wants to talk tonight?
Hey, this is Alan. I just managed to get back on. I wonder if you want to end with a little movie.
Okay, fair enough, Alan. Did you make the movie, or is this just something you found on YouTube?
No, this is something I made. It was, yeah. So it's a movie I made out of Predict 413 time series. Maybe I should share my screen here. So let me give you a little preamble. So as we all know, this is that course was done in R, and R has all these wonderful little procedures to do various types of modeling, and they all have these interesting little variables that they don't quite explain very well about how they operate, and it always drove me crazy. It's like, what's this alpha, or what's this, B variable or something like that. So, and I figured, I just need to figure out what this thing is doing. So this is from Predict 413, the homework 3, and it's, hang on, let me share my screen so you can kind of start to see what I'm talking about. All right, so, and since it's an R, I had to call the movie R Wars. And
I like.
Although I don't have the music because I couldn't get the rights. So let's see if this thing starts up.
We'll all hum it in our minds.
Okay, hum it to yourselves. Kind of do this. Oops. Hang on. Let me pause this for a second. Whoa. Okay, hold on. Whoa. Okay, so this is the homework problem, chapter 7. It's paperback book sales by day. So the black line is like, here's the actual sales by day. And then what we're trying to do is just fit the curve using simple exponential smoothing, which is...
Well, I don't see a movie yet. I see a bunch of graphs on the screen.
Right. So, hold on. Whoops. Hang on. I'm sharing the wrong screen here. Hold on a second. Let me stop and share my other screen. Let's share this screen and start it up. All right, now can you see a single graph? Okay, so what we're looking at is paperback sold by day, and then the blue dot line, that's like the curve fit. And what each frame of the movie will show you the value of alpha, simple exponential smoothing that it's going to use to see how well this fit. And then it's the sum of squares error. And down from, this is alpha of 0.001. That's the minimum value. So the SSE is 40,000 something, and it'll go down to 30 something thousand, and it'll start going up as it's getting overfitted. But let me rewind the movie to the beginning, and you guys can start humming. All right, you ready? So you gotta watch SSE real carefully. And right at about alpha equals 0.2, it hits the minimum. And then it starts to go crazy because it's really starting to try and map its exponential smoothing to the curve. So now alpha SSE is back up to what it was originally when it was just at a straight line. Dun, da, 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 da. Alpha goes from 0.01 to a value of 1. And, you try to read the explanation of what alpha means, and it's like, I don't quite get it. So I just had to watch it. So you can see now it's pretty much mirroring the actual sales, and it's the SSE is way, way out there because it's super overfitting. And so it's trying to map what it sees in the sales with what its curve is. So alpha went kind of bonkers. So let me see if I can find you the code.
What did you use to make the movie? Is it in R to make the movie, or?
Yeah, it's R, and then in the code I just had it dump each plot to a JPEG, and then I used a movie maker and just poured all the JPEGs in there, and each one plays for a half a second. Yeah, so that's the movie magic. Let's see if I can find, where's my code? Here we go.
So you just simply ran the same thing with a different alpha value, and then you just look to see what your sum of squared errors. I look at the very last one here, and I don't understand why has it got such a high sum of squared error. It looks like it matches it completely.
It's super duper matching it, but it's the and that's what I couldn't go to figure out. Okay, so it's an exact mirror of the actual sales. It's just like off by 1 day or something. So it's like, this should be awesome, but it's like it's overfit, and that's about as far as I could figure out what the heck it's doing.
Well, I think if I can see, if you look at two, like the blue dot and a black dot in the same line, there's a huge difference, even though it's off by 1 day.
So if you look at like day 23, the blue line is way down here, but the actual sales is way up here. But yeah, it's like everything's offset by a day. See if I can find you the code here.
Hey, Alan, isn't that expected? Because even when you're overfitting your time series, the alpha that you're setting is saying how far back you should go, but it's always going to be on a lag because, think about your stocks that are trading. It's always like you're taking historical observations and applying it going forward. And if you're fitting it that tightly, which is I guess what 0.99 is, you're just like basically saying follow the curve. Yep. You're going to have an exact match, but it's got to be on the lag, and it's going to be on the unit that your time series unit is up to. So this is actually what I would expect to see.
Yeah, because let me kind of zoom back to the minimum SSE is around 0.2 something. I think this is somewhere in here, right here. So this is best fit, right? So it's sort of obeying the actuals, but it's also kind of it's doing the simple exponential smoothing. That's kind of what we wanted it to do. And I'm looking through my code, looking for the place that it does all that cool looping. Anyway, it's a loop. The index variable is alpha. It loops from 0.01 to 0.99. And then each time I get a plot, I just dump it to, here we go.
And you have the R code for this as well?
Yeah, I'm looking for it right now.
Well, if you could post it to the discussion board, I'll move. Is it okay for me to move it over to the 411 students and keep it in there?
Sure. Here is, let's see. Am I showing my RStudio screen? Are you seeing that now?
Yes, I am.
Yeah. So this is kind of it. Hang on, let me get you a little bigger screen. Yeah, this is basically it. So give me alphas from 0.1 to 0.99. Start with SSC squared out, and then here's the for loop. And then I plot it. This isn't, but this used to save this to a JPEG. What happened? Okay, well, anywhere, somewhere in here, I wrote some code to do this, but this is the basic idea. Loop through all the alphas, do this SES on, this array, set the alpha parameter to whatever the index alpha is, like that. And then give me the SSE for that and save it away. There it is, pretty simple. But yeah, it really helped me to visualize what are these funky parameters doing. So I think that's
very
the show.
nice.
Yep.
I like this brute force use of R. That's kind of cool.
Yeah, right. Okay, that's all I got.
Hey, I still find this to be very useful. I'd love to, when you get all the code together, post it on the discussion board if you can. I'd like very much to play with this code as well.
Sure, will do. All right, end of the movie's over. That's it. Please exit the theater.
Great singing.
Yeah. Da, 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 da.
Pretty good. I even like the musical accompaniment.
I ain't no John Williams, but we do what we can.
I think you did just fine. So, hey, does anybody else have any questions for Alan before we? And anybody else have any more volunteers for the night? Okay, well, I'm going to stop recording.